morning students. Today we discuss about previous JEE Means problems in work, power and energy. So in this case, this is a problem number 1. So here a block of mass small m laying on a smooth horizontal surface is attached to a spring constant K. The other end of the spring is fixed as shown in figure. So the block is initially at rest. This is a very important point. In its equilibrium position, if now the block is pulled with constant force F, the maximum speed of the block is. We can find out the maximum speed of the block. Now we will draw the diagram. So here, this is the smooth horizontal surface. Block is arranged. One end is, and the block is arranged to this spring one end. Another end of the spring is attached to the rigid support. Now the force is constant force acting on the block in forward direction, but the spring force is opposite direction of the applied force, pulling force. Now we can find out the maximum speed of the block. Okay, so here spring constant F equal to Kx. Here x is the displacement of the block or elongation of the spring. So x equal to F by K. Now applying work energy theorem. Applying work energy theorem. Total work done. So here total work done is the sum of the work done by the force and the spring force is equal to change in kinetic energy. So in this situation, work done by the force, that is the F into X. So here spring force is opposite direction of the pulling force. That means it is a restoring force, minus half Kx square is equal to. So here change in kinetic energy, final kinetic energy minus initial kinetic energy. So here when the block is at initially at rest position, so here initial kinetic energy is 0. So therefore F into here x is F by K minus half K into here x means F by K, here x square, that means is equal to final kinetic energy is half m v square. Okay, so now therefore F square by K minus 1 by 2 F square by K. Here K cancel is equal to half m v square. So therefore 2F square by K minus F square by K equal to mv square. So in this situation, here we can common the term is 1 by K. So 1 by K is common, 2f square minus f square equal to mv square. So therefore f square by K equal to mv square. So in this situation, v square equal to f square by mk. So therefore v equal to root over f square by mk. So this is the maximum speed. Right. Now problem number 2. A force acts on a 2 kg object so that its position is given as function of time x equal to 3t square plus 5. What is the work done by this force in past 5 seconds? So this is the problem. So this problem is asked in JEE NEET 2019. So we can solve this problem. Here given position x equal to 3t square plus 5. So now we can find out the velocity. Velocity means the rate of change of displacement is known as velocity. So therefore d by dt of 3t square plus 5. So that means 60 plus 0. So therefore v equal to 60. So here if t equal to 0 second, that is the initial time, its velocity is 0. But if t equal to 5 seconds, its velocity is 6 into 5, that is the 30 meter per second. So here when a body is at 5 seconds, its velocity is 30 meter per second. So now according to work energy theorem, according to work energy theorem, W equal to change in kinetic energy. So W equal to here change in kinetic energy means final kinetic energy minus initial kinetic energy. So in this situation, here initial time its velocity is 0. So initial kinetic energy in this situation is 0. So therefore final kinetic energy is half mv square. Half into here mass of the body is 2 kgs into here v square is 30 square. So here 2 cancel. So therefore total work done W equal to, so 30 square means 900 joules. So this is the work done. This is the answer. Now third problem. A block of mass m is kept on a platform which starts from rest with constant acceleration g by 2 in upward direction as shown in figure. So now you can find out the work done by the normal reaction on the block in time t is. Okay. So in this problem, when the block is which is starts from rest. So here, when the block is initially at rest position. Now a constant acceleration g by 2 acts upward direction. So now we can find out the work done by the normal reaction. Okay, we can solve this problem. So here in this problem, normal reaction acting upward direction, but weight of the block acting downward direction. So therefore, resultant force acting of the block in upward direction. So therefore, resultant force F equal to N minus mg. According to Newton's second law, F equal to ma, m into, here acceleration is g by 2 equal to n minus mg. So therefore, mg by 2 plus mg equal to normal reaction. So therefore, normal reaction equal to 2mg plus mg, 3mg by 2. This is the normal reaction. Now we can find out the displacement using the equation. Displacement S equal to ut plus half at square. So here, when a block is initially at rest position, here initial velocity is 0. So therefore, S equal to half at, here A is g by 2 into t square. So therefore, gt square by 4. Here displacement is gt square by 4. So now we can find out the work done. Work done equal to force into displacement. Here force is normal reaction. So we can find out the work done by the normal reaction equal to N into S. So work done equal to, here N is 3mg by 2 into, here S is gt square by 4. So therefore 3mg square t square by 8. So 3mg square t square by 8 joules is the work done by the normal reaction. So this is the problem. Now problem number 4. A particle which is experiencing a force given by F bar equal to 3I cap minus 12J cap. This is the force. Undergoes a displacement of D bar equal to 4I cap. If the particle had a kinetic energy 3 joules at the beginning of the displacement, what is its kinetic energy at the end of the displacement? So here force and displacement are treated as, in this question, it's a vectorical forms. Now here 3 joules is the initial kinetic energy. Now we can find out the final kinetic energy. Okay, so we can solve this problem. So here force F bar equal to 3I cap minus 12J cap, and displacement S bar equal to, that is can treat it as B bar is equal to 4I cap. Now we can find out the work done. Work done, W equal to the dot product of force and displacement. So F bar dot B bar, that means 3I cap minus 12J cap dot B bar 4I cap. So here I cap dot I cap 1, 3 into 4 12 plus J cap, ikkada J cap value 0, so 12 joules according to work energy theorem. So W equal to change in kinetic energy. So W equal to final kinetic energy minus initial kinetic energy. So in this problem, initial kinetic energy is 3 joules. It is given. So therefore, work done equal to 12 equal to final kinetic energy minus initial kinetic energy is 3. So therefore, final kinetic energy is equal to 12 plus 3. That is final kinetic energy is 15 joules. So this is the answer.